This is a scaled down version of a game I'm working on. It's a sandbox to reproduce an issue without having the rest of my code interfering. Observe the trajectory of the ball, you see something's wrong. That's not how you expect a breakout game to have the ball move around. Press D in order to activate the physics debugging. You can see that each tile has its own body. And the problem occurs whenever the ball hits a corner between two tiles. So the tiles are created based on the collides property of a tile. This is tiled, my editor. I select from my tile set the green tile and I see that the collides property is a boolean set to true. Moving now to my code. I'm in a very standard phaser scene. The create method calls a createLevel method, which will create the tile map just using the boilerplate code. Create tiles from phaser parsing is to separate the built-in script from the script I made. So the built-in script, whatever custom shape that was made using tiled needs to be collidable. Whatever tile that has this collides property must be collidable, and then we ask the built-in script to convert every tile identified by these two methods to be converted into its own body. One body per tile. Then some post-processing, which is certainly not scary, it's just a way to say, within this layer, I want to do this for each tile. For each tile, I want to enrich. It's a fancy word to just say based on the collision category. Back to tiled. I see that I had created a collision category. Some are bouncy, some are not. Obviously this tile set is not fully complete. The second level has it. So we have collision category bouncy, orange one is mud, weird one is ghost, and so on. So it's simply applying friction, restitution, sensor, etc. to the tiles. So that's the first part of the post-processing. The second part is simply applying the collision filter category based on the name. So we have mud, we have bouncy, etc. This method here is simply matching a user-friendly name to a machine-friendly number. So these are just normal category for filtering. It's binary, and the non-relevant zeros have been cut down in order to have the relevant zeros aligned. It's easier to see that they are unique this way. That's not the point. So create tiles from phaser parsing has for result the creation of tiles. They have properties, they have bounciness, they have everything we need, but there's way too much corners and the ball hits the corners and that goes wrong. So keys, it's D to toggle debug graphics, R to reset, left and right arrows to move from between levels, and also of course mouse click to grab or throw the ball. Let's move on. You see my URL level 1 now. This is my other level that contains different tiles. So there is the fancy custom shape, just a test to see that it works, a sensor, the ghost, the weird ones, and the two new colors, orange and beige. Orange is mud, beige is bouncy, just like the green, but the green ones. But if I activate debug graphics, I notice now that beige and orange, they are one large single polygon. Orange uninterrupted, beige is interrupted because matter doesn't want to have concave bodies. So if it detects anything concave out of a set of polygons, it simply creates different subparts. It's a single body made of multiple parts. The good news is that the ball will not bounce in a weird way. Yes, mud sticks the ball. We can let it bounce as much as we want. It will not act funny anymore. Now it's serious, it's working. We won't have these weird collisions. If we want, we can have a quick look at the code, but technically what it does. the code back to my createLevel function. So first there was the built-in script, and then my script. My script is certainly not perfect, but so far it does the trick. It doesn't lose the properties of the tiles, and it seems to cover my needs. I hope it covers yours as well. So, phasor parsing. We collapse this one because we just want to see how to use my script, just in case you want to use it as well. Please note that it's important to first allow phasor to use its built-in scripts, because the first thing we do after the creation of the default shapes and the custom shapes using phasor built-in scripts is that we add another collision by property, which is not collides anymore, but island. So look at the green one, it's got collides, it's a boolean. Then orange, it's got island, it's a boolean as well, and I put it in uppercase to show that it's my own stuff. So you can tell them apart. Beige one, it's the same, it's bouncy, but it's an island. The ghost, it's ghost, but it's an island. That one, of course, has a custom shape, so we don't have to say collides, we don't say island, we let the built-in script take care of it. And the sensor, for some reason, I made it island as well. It's a sensor, and it's got this island property. This translates into what? It translates into that call to create tilemap island bodies. I call it islands. Maybe there's a better word or an official term for this. It's the only function that's being exported here. We'll go through that. But first I draw your attention onto two more things. The two approaches share this in common, is that there's some post-processing. It's optional. You don't provide the last object, then no processing happens. If you provide it, it has the setBody properties that will simply enrich the tiles, enriching being I set the bounciness, I set the friction, I set whether it's a sensor or not. So this is enrich. And then setting, or at least giving my script a way to know what collision filter category a tile or a tile island should be based on the user-friendly name, mud, bouncy, etc. Have a look at create tilemap island body. That's a separate file. You just have to copy paste this into your workspace. The link is in the video, but technically it's on GitHub. It's open source. You just go to assets, utils, matter tilemap utils, and this is the file. Just copy paste it, and I hope it helps. What it does, it's a two-stage thing. First, it identifies groups. So what is a group? Let me quickly explain. We take this here. Can't I just remove that? Okay. Voilà. I've got my mouse cursor. We know that the orange one is mud and the beige one is simply a bouncy wall. They have different collision categories, even though they both have to be treated as islands. Because the collision categories are different, even though they have faces in common, they belong to separate groups. I could very well add a few, let's go crazy. I could just add another group, so they don't have any physical connection. That will create a second group. So that's the one deployed on the web, and that's the one deployed locally. Here we go. I observe, I see that they share one envelope. To avoid being concave, Matter has cut them into sub-shapes, but that is one big island. That is one big island, and here that is one big island. So as long as they have at least one tile of the same collision category connected, they will create a chain, an island. Tell me about a better word if there is an official term for this. So I remove that. So the first step was to create those groups. We identify them because they are islands and because they are of the same collision category. Yes. The second thing they do, this script does, sorry, that for each group that we identified, we turn it into an island. We provide optionally the post-processing. Like I said, it's optional. You don't have to. If it's confusing, just forget about the last parameter. Just provide your scene and the tilemap layer that needs to have islands. That's not what we're looking for. Turn groups into islands. So what it does, I won't bore you by going into implementation details. I'll just show you here using tiled. Since I'm scanning from top to bottom and from left to right, it always begins a group with the upper left tile. This one, that one, that one. It takes the upper left vertex, so a corner, like I sometimes call them. I'm not a native, so sometimes I don't use the right words. Sorry about that. So what it does first is look right until you find either the end of the line, and then you identify this vertex as being the last one, or if there was another tile of the same collision category perpendicularly, counterclockwise, then it would identify the vertex and start in a different direction. So in this case, it's pretty easy. Reach the end, move left, reach the end, move up, move left, move down. I think you get the picture. It will identify the envelope of the polygon, envelope or shape. And when it reaches a vertex that it has already found, it stops looking. There is one issue, is you can't make a closed shape. So this is a closed shape and you can't play inside because it creates the polygon supposing that you will interact from the outside. So the trick I found so far is to simply to cut the polygon with a different type of collision category. It's an improvement I need to make, is that whenever you identify a vertex that you have already found, then the script has to add a vertex or a side in order to close the shape and still allow to play inside and outside of the shape. So far this works properly. Using this set of vertices that has been identified, we simply create a shape. That's what the script does next. So turn group into island. There's a do while here that does exactly what I said. Look right until last in line or has stop. It's always like in a labyrinth, you have your left hand on a wall and you move until you either reach the end of a corridor or have something to your left. That's the way it works here. So once it finds a vertex already in group, it considers that it's done. We create a tile island object that will be the game object of the body and of all the subparts, if any. We simply have to move the island. If I don't, what happens? Well, the centers of mass are, yeah, that's bad. If we don't, the center of mass will be the center of the body, and it might create an offset between the tiles and the physical representation itself. So this simply makes sure that the physical representation is matching the position of the tiles. If a post-process object was provided, we just enrich the body with the properties. So we know that it could be mud, bouncy, so it adds friction, it makes it a sensor, anything. Then the second part of the post-processing, where am I? Okay, is obtain the collision filter category name from the properties. If any, just obtain the number, the binary number, and associate it to the collision filter category to filter allowing or not collisions. Oh, sorry, this is broken. Refresh. There we go. So even though this one has a body, I don't instruct the ball to bounce against ghosts, so it doesn't. it doesn't trigger any sort of reaction. Look, in here, it doesn't show that you are bouncing with a ghost. However, when you cross a sensor, look here, it says sensor whenever you cross it. So there's the distinction between a ghost or whatever has been filtered out, doesn't trigger any collision, or a sensor which triggers a collision but doesn't interfere with the physical reality of what happens. The rest is just a series of internal functions. I tried to make them as readable, oh, this one is not in use, as readable as possible. Hope it helps, really. If it doesn't, well, we can discuss it. Otherwise, hope it helps. Have a great day.